So what's going on, guys? DIY Dan here again, and this is another mechanical video. In this video, I'm going to be replacing the electric brakes on my 26-foot enclosed trailer that I bought off of CRAIGSLIST. Now, the reason I did have to end up replacing these brakes was because the person that had this trailer before me was not adjusting their electric brake controller correctly in their vehicle. And because they were not using that electric brake controller correctly, they destroyed both sets of brakes on this trailer. So the first part of this video is going to consist of a step-by-step disassembly of the electronic brakes. After the disassembly, I'm going to be doing a component inspection to help show you what you might need to replace or what might be bad on your electric brakes. After that, I'm going to show you how I adjust my electric brake controller for each trip that I make depending on the load I'm carrying in the trailer to help you prevent doing what I had to do in this video. Then towards the end of this video, I'm going to be doing a step-by-step assembly of the electronic brakes. That's going to include how to pack your wheel bearings and how to make your wheel bearing adjustment. I'm also going to go over common mistakes that are made along with helpful tips that I've learned over the past 20 years of doing this kind of work. So let's get to it. So right here, I just jacked up the trailer. Now, because this was a torsion axle and not a leaf spring, I put it on the frame rail. Sometimes it's easier with a leaf spring trailer to just jack it up from underneath the axle. Then I pulled the tires and wheels off of the one side of the trailer. Now, I did use a jack stand, but it's also a good idea to take your tires and wheels and stick them under the frame rail of the trailer, just in case, especially if you don't have a jack stand. In case that jack slips, you have that extra support so it won't fall all the way to the ground if you're working underneath it.
Now, if you are just looking to check your wheel bearing adjustment to make sure it's good and to make sure your electric brakes are working, you could jack the trailer up like this without taking the tires and wheels off and have your trailer hooked to your vehicle that has the electric brake controller. Then go ahead and hold the manual override button on your electric brake controller and check to see whether your brakes are engaging and disengaging with that override button. And then also check your wheel bearings. And if everything's good to go, let it down and call it a day.
So the bearing adjustment's good on that one. Bearing adjustment's pretty good on that one too, but that's our problem. That one feels pretty good. Hopefully the brakes are good in that one. So sometimes these dust caps are loose enough where you can just grab them with a pair of channel locks and leverage them back and forth and they'll pop off. But you do have a chance at denting that dust cap if you just take a decent sized flathead screwdriver and a hammer, put the flathead screwdriver on the seam between the hub and the cap, and then tap it with a hammer. It'll break that seal and then just go around that hubcap, twisting the screwdriver to pop it off, and you never damage the hubcap. Depending on the axle you have, there is a couple different types of retaining clips to keep the wheel bearing adjustment nut from walking off and losing your tire and wheel. So mine has the actual cotter pin style. The stupid thing is, the axles that I have on this trailer, the hole goes offset in the axle, which makes it a lot more of a pain in the ass to get that cotter pin in and out than the axles that have the cotter pin going straight through the center of the axle, which are a lot easier to get in and out. I find that a pair of dikes is the best thing to remove these cotter pins. The first thing you're going to want to do is bend the two tabs back as straight as possible so it's easier to leverage them out of the hole from the other side.
Then use the dikes to pinch the other side of the cotter pin.
And then leverage it either against the nut or the outside of the drum to help you get those out. You could also grab it and pinch it and then use a hammer to kind of tap the dikes in order to help push it out as well.
Now, if you have one of the other style of spring-loaded clips that goes over the nut, you're just going to pop that off, usually by hand, or possibly use a screwdriver to leverage it off as well. If you have this style of retainer, then you're just going to take a flathead screwdriver or a pick and bend that tab in off of the castle nut in order to make it so you can remove that nut. Now, if your wheel bearings were adjusted correctly, you should be able to remove this nut by hand. However, this nut was catching on the threads a little bit, so I did have to use a pair of slip joint pliers just to help get it off of there. Once you get the nut off all the way, then I like to put my hand under the front of the hub to cradle that wheel bearing. So as you pull the drum off, you catch the washer and that wheel bearing in your hand so you don't drop it, possibly damage it, or get it dirty. Usually the washer will fall right off. Sometimes the bearing will get stuck because of the grease against the race, and I just bring it off and set it down with the bearing in the drum still. You'll notice as I pull this one off, this is the one I was really worried about, that pieces started falling out from underneath the drum as soon as I pulled it off. If you're pulling multiple drums off at the same time like I am here, make sure you keep your bearings with the drums they came out of. You want to consider those bearings a match set, and you do not want to intermix them with other races and bearings.
I've found that the easiest way to remove a seal is to take a pry bar and put it underneath the lip of the seal and push it up against the hub tightly. Then using a crescent wrench, twist the pry bar to leverage that seal out of the hub. Now this video is of a different drum, not the ones off of my trailer, because I actually forgot to video me taking the seals out of those ones, but the concept's going to be the same. Once you get it leveraged up a decent amount, then usually you can just take the pry bar itself and leverage it against the hub to finish removing the seal.
So now we're going to get into the inspection of the components, including the drums, bearings, and brakes. So when you have a situation like this, the easiest way to go here is just replace the entire backing plate assembly. It's the cheapest, easiest, and fastest way to get you back on the road. Now the life on these shoes was all in pretty good shape. That's about the thickness. They come brand new. The problem was, since this guy had his brake controller adjusted way too high, he basically melted these things down and they all needed replaced. As far as the shoes go, you want to look for any cracking, pitting, or chunking out of the shoes themselves. If that's the case, you need to replace them so they don't start chunking out to the point where you go metal and metal and destroy the drums, because the drums are what really cost on these trailer brakes. Out of all 4 of the brakes that I did on this trailer, only one of them was still in good shape. If you inspect your brakes and they're still in good shape and you want to reuse them, make sure you inspect all of the springs, the upper spring or possibly 2 springs depending on the manufacturer, the 2 springs that hold the brake shoes in their location, and the lower spring that goes around the adjusting nut, and make sure those are all still in good shape.
You also want to take a good look at your magnets and make sure they don't look like they're melted in any way, shape, or form. I only had one of the 4 that was still in good shape, and it was the same one that had the good brake shoes. If these magnets are visually in good shape, you also need to test them with a 12-volt battery to make sure they do magnetize. So basically you just run a ground and a power to it. Then just find something made of metal. It can be a pair of pliers, or like I'm using this plate of steel, and make sure that steel magnetizes to the magnet and holds it pretty firmly. You can also do this test with the electric brake controller in the vehicle by jacking up the trailer like I discussed earlier, and pull that manual lever and have somebody back at the trailer spinning the tires and seeing if they lock up and disengage as you pull and release the manual override button on the brake controller. You also want to set the gain pretty high on this brake controller to make sure they are locking up and not just slipping during this test. The bottom line is, if you have bad brake shoes or a bad magnet, it's not that much more money to just get a complete backing plate assembly, and then you have all brand new parts, and it's a lot easier to switch them out versus trying to piece together shoes and a magnet separately. Now let's say that you do have good brake shoes and your magnet's working properly. What commonly happens is when you go to pull the drum off, the little clip that holds the magnet falls off, and if all you need is the little clip, then that is something you can buy separately and just snap it in position to hold the magnet on while you put the drum on, and you're good to go. One thing you want to make sure of is that the spring that's underneath the magnet that holds the magnet against the drum is still there and in good shape. Then you just put the magnet over the top of that, and the clip depresses down and goes into the little detents that are on the lever that holds the magnet to the brake assembly.
As far as the drums go, you want to make sure there's no really deep grooves. This is the one where the brake assembly came apart, so it does have some grooves in it, but drums are rather expensive, so I'm going to run with this and see how it does. You're also going to want to look at the surface where the magnet runs and make sure you don't really have any deep pitting or grooves in that as well. This is still in okay shape. If that has some deep cuts in it, then your magnet's not going to be able to pull as strong and you're going to have a weak brake.
Because obviously the less surface area that magnet has to pull against, the less effective that brake is going to be. After cleaning off your bearings, check for any pitting, scarring, or grooves in the bearings themselves. If so, you will want to discard those and get new ones. If you do inspect your bearings and you need to replace one or both, you will want to replace the races that match up to those bearings as well. Otherwise, that old race will most likely destroy your new bearing. The only thing I was lucky enough with this project is my wheel bearings were still in good shape, and all I had to do was the brakes. So now that we've gone over all the components to the electric brakes, I'm going to quickly explain how they work. So when adjusting your trailer brakes, right now I've got an empty trailer on. So what I do is I don't use the foot brake. I use the manual override here, and I just pull it and feel whether it slows me down. What you don't want is for it to lock your brakes up. And obviously you still want to feel some drag so you have enough braking power to assist you when you're braking. So that's pretty good. That's actually, I'm going to lower it down just a little bit because I am empty. So that's good right there. I don't know if you can notice it's slowing me down a little bit, but it's not jerking me. So that video clip I just showed you is the first thing I do whenever I pull a trailer with electric brakes while I'm on the side streets or in my subdivision just leaving my house. Depending on the load I have, I adjust that gain. So obviously if you have a trailer with electric brakes, then you have an electric brake controller in your vehicle. That electric brake controller sends a variable voltage anywhere from 0 to 12 volts depending on the amount of gain that you set on the brake controller. And that variable voltage goes to the magnet that is on the brakes. When that magnet gets voltage, it pulls against the surface of the drum, and that pulls that arm that is connected to the magnet, which applies the brakes. Obviously, the more gain is the more voltage that is going to be put to that magnet, and the harder it's going to apply those brakes. One of the biggest mistakes I see with people making with these electric brakes is they adjust their controller way too high, so the trailer is doing all the braking, and they're barely using their vehicle brakes. Therefore, it's overheating the trailer brakes, and that's what destroys them, and the reason I'm having to replace all of them on this trailer. To remove the backing plate assembly, all you have to do is clip the 2 wires that go to the magnet. Leave yourself enough slack so you definitely have enough wire to hook the new ones back up. And keep in mind you need to have enough slack in those wires for that suspension to flex back and forth and not pull apart your wire connections. Then you will need to remove the 5 nuts that hold the backing plate assembly to the axle. Usually these are studs, so all you need is an impact or a socket to remove them from the front side. On the front axle, I loosened all the nuts off, then pulled the backing plate off, then cut the 2 wires for the magnet. When cutting those wires, I tend to cut them right where they were butt connected before, and that way I know I have enough slack in those wires for suspension flex when I hook them back up. So right here, I'm just installing the new backing plate assembly. So one thing I did do when putting this new brake assembly on is I did add lock washers behind the nuts to help secure those. There was none on the ones originally on this trailer, and that's just my peace of mind, making sure there's an extra little holding power to those nuts. One of the most common mistakes that I see with people with doing these brakes is they don't realize that there is a right and left hand side to these backing plate assemblies, and they've installed them reversed. Now, a lot of the times when you buy new brake assemblies, they will be labeled R or L for right or left side. However, if you're reusing yours or for whatever reason they're not labeled, the best way to determine whether they are going the right direction is if the backing plate is on the trailer axle, the arm that holds the magnet should curl around the front of the axle. If it's curling around the back side of the axle, then it is on incorrectly. As far as tightening these nuts down, I used my 3/8 rigid impact, which is a good torque for these size nuts. They are a 3/8 stud using a 9/16 socket. A 1/2 inch impact, you might snap them off, and if you're doing them by hand, just make sure they are good and tight. When tightening these down, make sure you don't pinch the wires for the magnet between the backing plate and the spindle. So here is a right-hand side brake. You'll notice the arm is going to come around the front of the axle if it's on the right-hand side. And here's a left-hand side, and that arm will be coming around the front side of the axle if it's on the left-hand side. So if that's reversed and the arm is coming around the back side, you are on the wrong direction and will lead to components coming apart and your brakes not working properly. When making the wire connections for the magnet, I tend to use the uninsulated butt connectors and then go over the top of them with heat shrink to help protect from corrosion, water, etc. I also highly recommend getting a good pair of wire crimpers like the ones on the left. A crimper like that will give you a lot more reliable crimp. They're a lot wider
and you can get more leverage when crimping down on them because of their size. So most likely you're going to have to do the final connection points between the brake assembly and the axle after you install it, but it's helpful to do as many of those connection points and strip the wires back so they're ready to go before you install the brake assembly, so it's easier to do. So you only have to do the final 2 connections once everything is up and you have less room to work. So if you're worried about wiring these in backwards, there's no such thing. As long as you connect the 2 wires to the magnet to the 2 wires on the trailer, it does not matter which direction you put them. Sometimes with small wires like this, depending on the size butt connector you have, it might be helpful to strip the wire back twice as far and bend it over. That gives you more wire in that butt connector to make a better crimp. And then I just use my butane torch to melt that heat shrink down onto the wire for that waterproof connection. Obviously a heat gun or just a house lighter will work as well. Now, being as though I had these shipped from Amazon, when I put one on, it was a little bit out of whack. It had just got shifted during shipping, and all I had to do was pop it back into place and make sure it was centered on the backing plate assembly. It's also a good idea to look at all your springs and all your pivot points to make sure nothing's binding and everything's in their correct holes like it should be.
So as we talked about earlier, my bearings were all good to go and I was able to reuse all of them. Now I do have a bearing packer, but for the purposes of this video with DIYers, I decided to hand pack these bearings to show you it's just as reliable. One thing you do want to make sure is that the grease you're using is designed for wheel bearings, and it should say on the grease tube. When packing wheel bearings by hand, I usually just squeeze some grease out of the tube and then either using my palm or my fingers, lay that grease onto the bottom of the bearing first and then push that bearing into the palm of my hand to help squeeze that grease into the bearing. I'll do that all the way around and then I will spin that bearing and go through that process 1 or 2 more times to make sure that I'm getting that grease as packed in there as possible. As I'm rolling that bearing with my hands, I'm looking for any dry spots on any of the rollers. And if I do have some, then once again, I'm going to layer that grease on the lower part of the bearing and work it in there with my palm. Once doing the bottom, and I'm pretty happy with the way that went, I did flip it over and do the same thing with the top of the bearing. So this is a messy process and I like to do them all at the same time. So if you decide to do the same, make sure you label or you set your bearings in a certain place so you know what drum they came out of so you don't get them mixed up. Once again, you want to consider those bearings a match set to the races. Once packing your wheel bearings and cleaning out the inside of the drums, you can set the inner bearing in place in the race in the drum. If your seals got so damaged during disassembly that you were questioning whether you have the right ones to replace it, you can always take that seal before installing it and slide it into place. It should take a little bit of resistance to push it on. Once you have it in place, you should be able to spin it by hand pretty easily. If you do this and something doesn't feel right, whether it's too loose or too tight, you might want to recheck to make sure you do have the right seals. To install the seals, I do have seal installers that would have made this a little easier, but for the purposes of DIYers, I'm just using this brass hammer to install them. A seal installer kit is basically a bunch of round aluminum plates that cover the seal completely with a center punch on it that you hit in order to seat the seals into the hub. When using a regular hammer, what you're going to want to do is lean the seal to one side, hold that side with your fingers, and then hit the opposite side on the outside edge of the seal in order to get it to seat into the drum. Once you get it to seat and not be flipping out, then you just go around the outside edge of that seal with the hammer until it is flush with the inside hub on the drum. It's also a good idea to take a mental note before removing the old seal as far as how far in or out it was so you can match that during reassembly. I can't emphasize enough how careful you need to be if you're just using a regular hammer to install these seals, that you need to be hitting the outside edge of that seal. If you hit the inside edge for whatever reason, there's a good chance you're going to damage it and it's not going to seal that grease in that hub. So right here, I'm just using some brake clean to clean up the axle before reassembly to make sure I have no dirt or debris on them. If you do have a grease cert in your axle, it's a good idea if your grease was old and nasty to pump some new grease through that grease cert to get that old stuff out of there before reassembly. As I mentioned earlier, before sliding your drum onto the axle, you want to make sure that your shoes are centered on the backing plate assembly. If you did install new backing plate assemblies, the drum's almost always going to slide right over those shoes and be at a good adjustment. Once sliding that in place, the shoes will hold that drum in place, and then this is just a personal preference. It's not absolutely necessary, but I like to goop that grease inside between the two bearings and fill that hub up with that grease. A lot of people think that you can use the actual grease zerk in the axle to do this same thing. However, that's not the case. The hole in the axle where this grease zerk goes to is in between the inside bearing and the wheel seal. So if you pump a bunch of grease into there, all you're going to do is push it out the grease seal and make a mess of your brakes. Once I have that hub pretty full of grease, then I'm just taking the outer wheel bearing, putting it in place, and the washer on top of it, and then putting the nut on and start tightening it down. The only thing I do with that grease zerk in the axle is pump a couple pumps of grease into it, maybe once a year, to produce more of a watertight seal between the seal and the bearings on the inside. If your axle uses the retaining washer with the fold-over tabs, it's a good idea to fold those down and make sure they're perfectly flat before putting them on, before you put the nut on, so the nut does not catch on those tabs as you make your adjustment. Now, because I pre-filled that hub with grease, you'll notice that as I start tightening the nut down, the grease is going to start pushing out towards the outside of the hub, telling us our hub is nice and full of grease. To make the wheel bearing adjustment, you always want to preload the bearings first. So I'm going to use these channel locks to tighten this nut down as tight as I can. Then back that nut off where you can turn that nut by hand. Usually that's right around a half to 1 full turn at the most. So normally I would just do the wheel bearing adjustment with the tires and wheels off. However, for the purposes of this video, because it's going to make it a little easier for me to explain the wheel bearing adjustment, I'm going to put them on real quick. So I just covered the hub up with a rubber glove to keep any debris from getting in it, and then tightened down the wheels in a star pattern, and then went over them one more time to make sure they were all tight. When I explain how to do this bearing adjustment, the term I use does sound pretty stupid, but it is about the most accurate term that I've found to describe what you're looking for when making this wheel bearing adjustment. The main reason I wanted to put the tire and wheel on to show you guys this wheel bearing adjustment is because it's easier to leverage a tire and wheel side to side to feel that wheel bearing adjustment than it is to do it with just the drum. To feel this wheel bearing adjustment, all I'm doing is putting one hand on one side of the tire and going 180 degrees with the other hand and leveraging it side to side. We're a little loose here, so I don't know if you can hear it, but you can hear a little tink tink. Okay? I'm going to show you what happens when you go too tight and when you go too loose. So right here we're going to tighten it up. So that is way too tight. You should never use a pair of pliers to do your final adjustment. No tink tink. Okay? If you over tighten your wheel bearing adjustment, you're going to overheat those bearings. They're probably going to seize up, and I've seen the whole tire wheel drum assembly come right off the side of the trailer when that happens. So we're going to tighten it back down, and we're going to loosen it back that half turn so it's loose. But I am going to go too loose now. That's like 1 full turn back. That's too much. That is way too much of a tink tink. Okay? So we're going to adjust by hand. Still a little loose. Right there, just a little tink tink. That's pretty good. I like that right there. Once you get the correct wheel bearing adjustment, it's time to put whatever type of retaining device in that nut or through that axle, whether it's the spring clip or the washer with the tabs that fold over that you have to put on before the nut. Whatever it is, you just put that back on there. When using a cotter pin, try and use the biggest cotter pin as possible, because obviously the bigger the cotter pin is, the tougher it is and less likely to shear. You'll notice because this one is offset that I put it in a little bit and then I bend it and then put it in a little further and bend it again, making it easier to get through that offset hole. If your hole for your cotter pin or whatever your retaining device is not quite lining up with the nut, just move it to the closest one and put your retaining device on, and then check your wheel bearing adjustment one more time to make sure you still have that nice little tink tink in your bearing adjustment. Always use a new cotter pin. Don't ever reuse a cotter pin. If you damage it for whatever reason when removing it and you create a weak spot,
it could shear off. And if it shears off, then your nut could possibly walk off, and then you're going to watch your wheel and tire and drum assembly go flying down the road, or it could go off into oncoming traffic and cause something a lot worse. For this same reason, always put your cotter pin in from the top of the axle. That way, if the two pieces of the cotter pin that you bend to lock it in place do shear off for whatever reason, the cotter pin won't just fall out of the hole and let your bearing adjustment come loose and come off the trailer. Another reason I'm not too fond of these offset holes in the axle for the cotter pin is because there does tend to be a little bit more play in the nut versus the ones that go straight through the center of the axle. Those tend to lock that nut right where they're at. You'll notice that as I'm bending these tabs of this cotter pin over, that the nut is moving a little bit. So just check your bearing adjustment after you're done bending the tabs to make sure you still have that tink-tink as well. So as I said earlier in this video, if you get new backing plate assemblies, the brake adjustment should be good. You'll notice as I'm spinning this, you can hear just barely a slight drag from those brake shoes to the drum, and that's what you're looking for.
Which it is.
You should be able to hear the shoe rubbing the drum, but it should not be slowing down the tire and wheel at all as you spin it. Just like the wheel bearing adjustment, it's better to be a little too loose with your brake adjustment than it is to be too tight. If you're too tight, it will create friction and heat, and I've seen those brake shoes expand to the point of locking up that tire and wheel because somebody adjusted them a little too tight.
Once again, this should not be necessary if you bought new backing plate assemblies. If you do feel that you're too loose or too tight and you need to make an adjustment, there is a slotted hole in the back of the backing plate assembly that you can use a flathead screwdriver or a brake tool to make this adjustment. To make that adjustment, you're going to go clockwise with the adjustment screw in order to tighten the brake shoes against the drum. And in order to loosen them, if they are too tight, you're going to go counterclockwise with that adjustment screw.
The best time to do this brake adjustment, in all honesty, is while you're doing the installation of the brake drum back over your axle before putting the outer wheel bearing back on, because then if it doesn't feel right, you can just slide the drum back off and do this adjustment from the front side instead of having to use the stupid screwdriver or brake tool from the back side, which takes a lot longer.
And keep in mind, I only popped that spring off to show you guys this adjustment a little easier. You don't want to pop that off because those can be rather obnoxious to get back on.
Then all that's left to do is pop your dust cap back on, make sure it's clean of any debris. Put one side in a little bit first, then tap it on the opposite side.
And then just tap the one side in just a little bit like that. Pop in the top. Work the way around. Good to go.
Now one thing you'll notice is I discarded the hubcaps that make the tire and wheel look pretty. I have a specific reason for that. Anytime I stop to get fuel or have to go to the restroom, I always go around my trailer hubs and feel the hubs to make sure they're not getting hot, in case I do have a bearing or a brake starting to give me a problem so I don't end up stranded on the side of the freeway. It doesn't look as pretty, but it's much more of an effective way to make sure you're not going to break down.
Hopefully you guys enjoyed this video and it gave you some good information. If so, make sure you hit that like button and subscribe to my channel if you haven't already. I'd really appreciate it. The whole concept of my channel is to give you guys the most information in the least amount of time as possible so I don't waste your time. And I hope to see you next time. Have a good one. Later.